Hello guys, welcome to my channel. So today's our Leetcode Daily challenge problem is minimum swaps to group all ones together. Okay. So what is the question state? Firstly, they have told what swap means. Swap means that if we can select any two distinct positions in an array and swap the values of them, right? Suppose I select this zero index and this particular third index, so I can swap it. So one would come here, zero would come here, right there, right? So and given that the given array is a circular array, right? Which means the first element and the last element to be adjacent, right? That means that 0 and 0 comes together, right? Suppose you write it in the circular manner. This is zeroth index and this particular index is 2, 3, 4, 5, 6, 6 index. After 6 index, 0 index comes. That is, this 0 and this 0 are adjacent to each other, similar to this, right? And what you have to do is, given a binary circular array, that is, the array contains 0 and 1 only, right? You have to return the minimum number of swaps required to group all the ones present in the array together, right? At any location. What we have to do is we have to apply the swap method, right? And we have to make all these ones contiguous, right? At any location. So what we have to do, return we have to return the minimum number of swaps, so minimum number of swaps so that these all ones becomes contiguous, right? And see, as it is a circular array, if one comes, if one this one comes here and this two ones comes here, then also they are contiguous because this is a circular array, right? Now for solving this particular, what I can do is, see, I will use the sliding window approach for solving this particular solution, right? So what I will be doing is I will select one window, right? Now, what would be the size of the window? It would be equivalent to our answer. What will be when we will get the answer? That is when all the ones are contiguous, right? When all the ones are contiguous, then we will get our answer, right? So that is equivalent to number of ones that are present in the array. All right. So what I will be doing is I will make one variable once, initialize it with 0, right? N is equal to nums dot size, and I will count all the ones, right, that are appearing in this array. So this, in this particular example, number of ones are 3, right? So here 3 comes. Okay. Now see, it is a circular array, so we have to handle this particular case, right? And it would become quite complicated, right? Because if here the number of ones is 3, so the window size is 3. So right, this 3 window is easy to calculate. Similarly, this 3 window is easy to calculate, but for this particular window it will become quite complicated, right? And if the window size is 5 or 7, then it will become more complicated. So there is a property of circular array. If you want to make a circular array similar to the normal array, right, that is the linear array, you simply append this particular elements to the same array. Okay, that is this array similarly appended to here. So basically 0 1 0 1 1 0 0. After that, this one 0 comes, 0 1 0 1 1 0 0. Okay, so the size of the array would be twice the size, the given size. Okay, and now basically see, uh, if I take here, right, like here I have basically append the array. You can use the function also to make you better understand. I have written this particular thing, right, in this order. See, what was the array? Our array was 0 1 0 1 1 0 0. Okay, now if I append the same array to it, okay, then what would our array look like? This. Okay, now it will behave like a linear array. Okay, now it would easy to find the windows, right? Because the window size was 3, so now I can calculate this 3, right? And from here, that is up till here, our the array was up till here, right? So basically now I can calculate this window also, right? I can calculate this window also of 3 size. Okay, that's why we have appended it. Now what I will do is I will simply initialize my n was equal to 2, but now our array size is twice the previous array size, so I have multiplied it by 2, right? Now I have taken one maximum variable and one variable. Now what I will do is I will simply uh, see the number of ones is equivalent to 3 in this case, right? So our window size would be 3. Okay. So I will traverse each and every window of 3 size of this particular array. So basically our new array. So basically this, right? So I will move calculate this 3. I will move to this 3 sub array. Okay. And now what I will do is I will check how many ones are there in this particular array. So here you can see there is only one, okay, and there are two zeros. So I will simply and we have to find the window in which the maximum ones arrives. That's why I have taken this maxi, right? So I will here the one number of ones is one only. So right, I will update my one with one and maxi with one. Okay. So now I will come to this window. Okay, I will calculate the number of 1 is equal to 2, and I will update by maxi was initially containing 1, and now is there are two ones in the window, so I will update it with 2. Okay, so at the end what would be our answer? The number of ones, that is the window size, minus the number of the maximum number of ones, that is maxi, right? That would be our answer. So for doing this, how can I do this? I will simply traverse through the array, right? And why I have written this n minus 1? Because see the size is 3. Okay, the size is 3. So basically I have to calculate till this index. Otherwise, when I will move to this index, then the array would go out of bound, right? It will give an error. That's why I have written n minus 1. 1 is equal to our window size. Okay, that is the number of ones that we have got. Now for each window, right? For each window, I will calculate from 0, from like from the index 0, the window would be this much, right? From one index, the window would be this much. Okay, for the second index, the window would be this much. Okay, so what I will do is I will calculate I from 0 to n minus 1s. Okay, and now I will initialize 1 with 0. Okay, basically I have done it twice. I can simply remove it. Okay, now from 0th index till ones, right? I minus I plus ones. I will calculate how many ones are appearing, right? And I will, if ones appear, then I will increment my one. And at the end, I will initialize my maxi with one. So in this window, I will get maxi is equal to one, right? In this particular window, I will get maxi is equal to two. Okay, in this particular window I will get max is equal to 2. Okay, in this way. So the maximum value for this particular thing is will be 2, and the number at the end what I will do, I will with the size of my the window, I will remove the maximum number of ones that are appearing in particular window, right? So here as you can see 2 were the the maximum value was 2, and 1 says the number of ones that appeared, that is 3, right? So 3 minus 1 would be 3 minus 2 would be 1, so it will give answer 1. Here in this particular example, right, the window size is 1 2 3 4 5. Okay, so similarly I will make a window of size 5, right? And I will check how many which window has the maximum number of ones. So this window would be the one with the maximum number of ones. Okay, so 3, so 5 minus 3, at the end I will just return 5 minus 3, that is equivalent to 2. Okay, now if I run it, yes, it is running fine, but here it will give TLE, because see, what would be the complexity of this particular solution? Our array size, that is n cross 2, right, into the window size, because we are using this inner loop which whose size is equal to the window number of ones. So right, in worst case the window size could be equivalent to the array size, right? That is n. So n cross n would be that is n cross 2 into n would be n square solution. Okay, that's why that is giving the TLE. And now can we optimize it? Yes, we can optimize it. So what I will do is, see, uh, if I comment it, right, and this would be our new solution. Let me remove this commented part. Okay, so this is our basically new code for optimizing it. What I will do is initially I will traverse through the window. See, in this particular example, the window size was this much. Okay, so I will take one window of this much size, that is 3 size. Okay, and I will calculate the number of ones, right? And the one variable is the same, and whenever the one comes, I will increment my one. So here in this particular window, one comes one time. Okay, so maxi is equal to one. I will update my maxi with one. Okay, so maxi is holding the one. Now what I can do is that instead of using the inner loop here, I can use the number of ones that I have calculated in this particular window, right? So now I will start my loop from here, okay? Because I already know how many ones are have appeared in the previous window, okay? So I will start from here. Now what I will do is I will check that if my nums of I minus 1, see the nums of I minus 1 would be this particular, right? That's zeroth index. It is equivalent to 1 or not. If it is equivalent to 1, then I will decrement my 1, right? And now I am here, right? If this particular thing is equal to 1, then I will increment my 1, right? So here I can, so basically what I will get this particular window, okay? So here, as you can see, the zeroth index was holding 0, so 1 will not be decremented. 1 was initially having 1, right? And here, as you can see, the first index is holding the value of 1, so I will increment by 1, so 1 becomes 2, okay? And I will increment by maxi, update by maxi with new updated one, okay? That is 2. So hope you have understood, right? Now where I will move to this particular index, okay? And I will check whether this particular index value minus this particular one's value, that is 1 or not. If it is 1, then I will decrease my one value, right? So 1 was initially 2, now it would become 1. And now I will check whether this index value is 1 or not. Yes, it is 1, so I will increment it. So 1 again becomes 2. So basically we have got this particular window, okay? And the maximum would be 2 only, the same. Now I will move to this particular thing, okay? This index. I will check that this index minus 1, that is one's index value, that is 0, that it is 0 or not. If it is 0, then I would do nothing. If it is the 1, then I would have decremented it. And I will check if this particular window is 1 or not. No, so I will do nothing. So basically this window size would also be 2, because it was same earlier, it was 2, now also it is 2, okay? Now I will move to here, okay, this 0 index value. Now I will check this was 1 or not. If it is 1, if it was 1, then I will decrement my 1 value, right? And now I will check this particular index if it is 1 or not. If it is not 1, so I will not increment by 1 value, right? So basically this, for this window, the one value size would be 1 only, and the maxi would be 2 only, because the maximum of 2 and 1 is 2, right? And this will go on because the window size here is n, but basically we have appended it, so it will go for n cross 2, okay? But now we have reduced our complexity from n cross 2 into n to n cross 2 only, okay? So the complexity would be O of n, right? At the end I will return the same. And now if I submit it, like, let me run it first. Yes, it is doing fine. And now if I submit it, yes, it is accepted. Okay, so hope you have understood the solution. If you understood it, please give me a thumbs up and subscribe to my channel. See you in the next video. Till then, goodbye.